Alright, starting with number 9 now, we're asked to find polynomial functions. And they tell us the degrees, they tell us the degree, and they give us, actually in this one they give us all of the zeros, and they want us to find the polynomial function. So, if negative 2 is a 0, that means that x plus 2 would be a factor. And if 3 is a 0, then x minus 3 would be a factor. And if 5 is a 0, then x minus 5 is going to be a factor. So what I need to do is multiply all of these and find the polynomial function. And it doesn't matter which ones you multiply first. You'll get the same answer at the end. So I'll just do the last two. X minus 3 times x minus 5. I'm going to use distributive property. X times x is x squared. And then my outers would be minus 5x. And then my inner will be minus 3x, and then my last, negative 3 times negative 5 will be plus 15. So to make it a little easier, I'll go ahead and simplify first. This is x squared minus 8x, putting these two together, and then plus 15. So now I got to multiply x plus 2 times this. So I'm going to multiply x times everything. So x times x squared is x cubed, minus x times 8x would be 8x squared, plus x times 15 would be 15x. And then I'm going to do 2 times everything. 2 times x squared is 2x squared. 2 times 8x would make minus 16x. And then 2 times 15 would be 30. So now all I have to do is combine my like terms and figure out which the answer this matches. Minus 8x squared plus 2x squared would be minus 6x squared. Plus 15x and minus 16x would be minus x. And then plus 30. X cubed minus 6x squared minus x plus 30. My answer would be D. Number 10, find a polynomial function with degree 3, and the zeros are 5. So that means x minus 5 would be a factor. 2i, so x minus 2i would be a factor, and negative 2i, so x plus 2i would be a factor. Again, it doesn't matter which two you multiply first. However, these last two are probably the easiest to multiply first because the outers and the inners, this is a difference of squares. So these will, when we multiply, will be a difference of squares. So the outers and the inners cancel out, which makes it just a binomial when we finish. So x times x is x squared. Then my outer would be plus 2ix, and my inner would be minus 2ix, which cancels. Then I have minus 4i squared. So I'll bring down the x minus 5, and this becomes x squared. These cancel. Minus 4i squared. Since I squared is negative 1, that becomes plus 4. So now I just multiply x minus 5 times x squared plus 4, and I get x cubed minus 5x squared plus 4x minus 20. X times x squared is x cubed. 5 times x squared is 5x squared. 4 times x is 4x. And then minus 4 times 5 times 4 is minus 20. And that's our answer for number 10. Number 11, same thing. Find a polynomial with degree 4 this time. So we got a little bit more multiplying. With negative 3 is a 0. Multiplicity 2. So I'm going to put x plus 3 down twice. And negative 2 is a 0, multiplicity 1, so that would make x plus 2 a factor once. And negative 1 is a 0 with a multiplicity of 1, so that would make x plus 1 a factor once. So it doesn't matter what order. I'm going to multiply the first two together and the last two together, and then I'll multiply those two answers together. So when you do the first two, you get x squared, and then I'd have plus 3x plus 9, or x squared plus 6x plus 9. And then here I'd have x squared plus 1x plus 2x plus 2, which is x squared plus 3x plus 2. So now I'm going to multiply these together. So what I'll do is x squared times everything. Whoops. And then I didn't go far enough. X squared times x squared is x to the 4th. X squared times 3x would be 3x cubed. And then x squared times 2 would be 2x squared. And then 6x times everything. 6x times x squared would be 6x cubed. 6x times 3x would be 18x squared. And 6x times 2 would be 12x. And then 9 times everything. 9 times x squared is 9x squared. 9 times 3x is 27x, and then 9 times 2 is 18. I know I'm running out of room there. So I get x to the fourth. Let's see, I've got a 3x cubed and a 6x cubed, which I can put together to make 9x cubed. Then I've got a 2x squared and an 18x squared, that's 20x squared, and a 9x squared, so that's 29x squared. And I've got a 12x and a 27x, so that's 39x, and then 18. So it looks like my answer is here. X to the fourth plus 9x cubed plus 29x squared plus 39x plus 18. Just a matter of basically doing distributive property over and over again. Number 12. Suppose the polynomial function of degree 4 with rational coefficients has 6. All right, so we have 6, 4, and the square root of 2 are zeros, and we've got to find the other 0. Well, 6, that's a rational 0, so that's a 0. 4 is another rational 0. Those don't come in pairs, but if the square root of 2 is a 0, then so is the negative square root of 2. Those work together. So the one that we don't have is B, the negative square root of 2. Number 13. Again, this time we've got degree 4, so we're looking for 4 zeros. 6 is a 0, and 4 is a 0. Those don't come in pairs, but 3i is a 0, which means that negative 3i would have to also be a 0. All right, number 14. Again, degree 4, so I'm looking for 4 zeros. This time they tell me 3i is a 0, which means negative 3i is going to have to be a 0. And negative 6 minus the square root of 3 is 0, which means negative 6 plus the square root of 3 is a 0. You don't change the negative 6. All you change is the minus to the plus right there. So I'm looking for negative 3i and negative 6 plus the square root of 3, which is B. Number 15. What if I know that one of the zeros is 2, and I've got to find 2 more zeros because it's a third power? So what I'm going to do is I'm going to do synthetic division to see what I have once I've taken out that 0, and it should go into it evenly. So 2 times 1 is 2, add, you get negative 2. Negative 2 times 2 is negative 4, add, you get 5, and then remainder of 0. So here's what I've got, x squared minus 2x plus 5, and that doesn't factor. So to find my other two zeros, I'm going to do the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4, I'm running out of room, a c over 2a. So I get 2 plus or minus the square root of, what would this be, 4 minus 20, negative 16 over 2. All right, I'm going over here. The square root of negative 16 is 4i. So if I divide everything by 2, I get 1 plus or minus 2i. So my answer is going to be A, 1 plus 2i and 1 minus 2i. So when they give you one of the zeros, do synthetic division, come out with a quadratic, and we did quadratics on your last test. So then it's just a matter of finding the other two zeros of this quadratic equation. All right, number 16, find all the possible, see, they're not asking what are they, they're just what are the possible rational zeros. So you take this last term and you find the factors of it. So the factors of 8 are 1, 2, 4, and 8. And then you look at your first term and you take the factors of it, and that goes as your denominator. So the factors of 2 are 1 and 2, and then you divide. So everything first divided by 1. 1 divided by 1 is 1. 2 divided by 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. And now I've got to go back and divide everything by 2. 1 divided by 2 is 1/2. 2 divided by 2 is 1, which I already have. 4 divided by 2 is 2, which I already have. 8 divided by 2 is 4, which I already have. So these are my possibilities. 1, 2, 4, 8, and 1/2. So it looks like my answer is B, plus or minus each of those terms. Let's see what we have next and see if I can do one more. Find only the rational zeros. So again, I'm looking for the factors of this last number divided by the factors of the first number, which is just going to be by 1. So the factors of 192 are 1 and 192. Let's see, 2 and 96, I think. 2 and 96. And then what I'm going to do is I'm going to see what works. 3 and 64. I'm going to run out of room here. Plus or minus 3, plus or minus 64, plus or minus 4 should go into 192, plus or minus 48. 5 does not, but 6 does. 6 and 32, that's a 64. 6 and 32. 7 does not. 8 does. 8 and 24. 9 does not. I don't think. Nope. 10 does not. 11 does not. 12 and 16. I think that's it. So what I want to do is I want to figure out which of these are actually rational zeros for this function. I know it's not going to be 5. That's not a choice. It's not going to be negative 5. That's not one of my choices. So it's either it's 4, negative 4, negative 8, and 6, or 4, 8, and negative 6. So I'm going to test this on my calculator. If you go to your y equals and look at this function, x cubed, I didn't get that written down, x cubed plus 6x squared minus 40x minus 192. Minus 40x minus 192. We want to see, just checking out, is 6 or negative 6. Looks like negative 4 is a 0. So which one I'm going to have negative 4 as a choice? This one. Negative 4, negative 8, and 6. Let's see. Is negative 8 a 0? Yes. What about 6, just to make sure? Scrolling on down here. 6 is also a 0. My answer is C. I'm going to pause this here.